Thought I'd try something new, a little bit of a video study guide. If you see the problem and you want to actually work it out, go ahead and pause it, otherwise I'm just going to walk right through it. I tried to keep it to big points and I'll try to keep it quick. So writing a log form in exponential form, you know the banana rule. So if it says 3 to the second power is x, we just wrote 3 to the second power is x here. And for this, if you wanted to solve for x, just remember, while you can write this, it's not necessary. Keep in mind too, if this is a non-calculator section, you probably wouldn't be able to do this anyway. You know that if it's a fraction, then the exponent must be negative, and then if I look at this, I can see that it must be 3. Likewise, if you see a radical, that triggers in your mind that has to be a fractional exponent. Don't be thrown off by natural log. Whenever you see this, you know that natural log is the same as log base e, which should be able to help out. And using banana law, you've got e to the x equals e to the 5th, in which case x has to be 5. Alright, unlike our first problems, when you know that 7 can't be multiplied by itself to get into 50, you will need a calculator for something like this. So in this case, this form would be appropriate. And you know to answer, we would just divide both sides by log 7. 2 parts to this one. Whenever you see a coefficient at the beginning of a log, we can actually rewrite this as an exponent. When you see this, it's imperative to look at the base. If the bases are the same, then you can just write this as 6 squared equals x to the 5th and solve. However, a lot of times you'll see something a little bit different looking like this. So if we don't have equals, which will likely be the case at some point, you might have plus or minus, in which case if you have 2 logs, you're probably going to simplify them or combine them in some way, and when you see plus, you know that means you have to multiply. So I can have log base 3 of 6 squared times x to the 5th, or since 6 squared is 36, I could actually just go ahead and simplify that further. The clue for this is when there are 2 logs in the beginning to combine, or at the end, if you're actually working backwards and you get something that looks like this, if you've got multiple parts within your log, you can actually break them up into addition or subtraction depending on if it's multiply or divide. Again, don't let natural log throw you off. That is just log to the base of e. You can either leave it in natural log form or write it as log to the base of e. To be fair, if you have an e in any of this space, you want to rewrite it to the base so that you can kind of see what's going on, but in this case we don't have to. So we're just going to solve it. Oops. We're going to break this apart, and since it's division, we're going to use subtraction. So this would be our answer, or again, we could write it as log to the base e of r minus 4 log to the base of e of c. Either one works. Honestly, this one's a little bit simpler, but if you wanted to actually see what was going on, or if you actually had an e and you wanted to simplify this any further, writing out this part doesn't ever hurt. A couple of miscellaneous things to keep in mind whenever you have x squared equals 4, or if you're finding anything for x squared, know that that is a quadratic, and so anytime you have squared, you know that you have 2 possible answers. So this could be -2 or 2, not just 2. Also, when it comes to graphing, keep in mind that your asymptotes help you with your domain and range. And ultimately, keep the big picture in mind. So if you see 2 logs, you know you're probably going to be combining them. If you see natural log with an e somewhere in that question, you know you're probably going to want to write it out and simplify into banana log or something like that, or banana rule or something like that. Also, keep in mind the section of the test. If it's a non-calculator, it's going to be something where you can kind of make a trick to write it out. If it's calculator version, then you are probably going to need to finagle it so that you can write log or use your buttons, but know where it is on the test, what you did before. It might lead into it, it might be a progression, and just keep in mind that you've done all this before, you've seen everything. When in doubt, just try the 1 or 2 or 3 methods and something will come up, and always check your work. One final add-on when dealing with growth and decay problems, using this as growth, so we'll just talk about growth, depending on what you're solving for. These could be easy or a little bit more difficult, but once you know the numbers, you can go with what you know with your calculator. So a quick practice problem here. If you start with 20 and we'll say our percent is 25%, our time is 3 years, and our compounding is every quarter, so 4 times a year, we can actually just simplify this as is and work this out from the parentheses out. I accidentally forgot to add the 1, sorry. And voila. Now, when solving for t, it's slightly more difficult. You'll probably see one of these on the test, and this is where log comes in. You can either simplify what's in here first, or you can divide both sides by 20 since both sides are since the right side is multiplied by 20. Either way, you're going to end up with, when you see this, you just go ahead and do log. And then go ahead and divide both sides by log 1.0625. Once you've done that, you can divide by 4 both sides and solve for t. Alright, 2 more things. Sorry, as I look through this, I realized I made a mistake on the growth one where you're solving for a. I put an extra 0 in the decimal point. So if you solved that and got like 41.4 or something like that, I think that was the correct one. My apologies there. Outside of that, don't forget you can always rewrite something if you have log on the right side and you feel more comfortable with it on the left of an equal sign. Make sure that you write it the way that you feel comfortable with it. You can rewrite, you can kind of rework the problem. Ultimately, best of luck. You'll do great. Same thing working backwards if we want to write this in log form.